For billions of years, Mars has stood as one of the most intriguing worlds in our solar system. A frozen desert of rust-colored soil, towering volcanoes, and vast canyons carved by forces long vanished. Today, the planet looks lifeless, dry, and brutally cold. But the more scientists explore its ancient surface, the more a shocking truth emerges. Mars was once a world with water. Not just droplets or seasonal ice, it had rivers that carved valleys, lakes that filled circular basins, and perhaps even a massive northern ocean stretching across the planet's surface. If that is true, then Mars was not always the dead world we know. It might have been warm enough, wet enough, and stable enough to support life. So the fundamental question becomes, what happened? How does an entire planet lose nearly all of its water? How does a world that once held seas become a cold, dry shell? To answer that, we must go back over 3.5 billion years, to a time when the young solar system was chaotic but rich with opportunity. During this early era, Mars and Earth were surprisingly similar. Both had active volcanoes, thick atmospheres, and surfaces being shaped by liquid water. Mars, despite being smaller, had the conditions necessary for a hydrological cycle: rain that fell from the sky, water that pooled in lakes, and rivers that flowed across the landscape. Clues of this watery past are written across the Martian crust: branching river deltas, sedimentary rock layers, and minerals that only form in the presence of long-lasting water. So why did this world, once vibrant, fall apart? The story begins with gravity, or more specifically with the lack of it. Mars is only about 1/10 the mass of Earth. This means its gravitational pull is far weaker. A planet's gravity is what holds its atmosphere in place. A smaller world cannot cling to its air as tightly, especially when exposed to powerful energy from the sun. Early in its history, Mars likely had a much thicker atmosphere that allowed liquid water to remain stable on its surface. But as ages passed, the planet began losing that protective layer, atom by atom. The second crucial factor is Mars's missing magnetic field. Earth is shielded by a strong magnetic field generated by the churning of its liquid metallic core. This shield deflects the solar wind, the stream of high-energy particles constantly blasting outward from the sun. Without this protection, Earth's atmosphere would slowly be stripped away. And this is exactly what happened to Mars. Billions of years ago, the Martian core cooled and solidified. With a quiet core came a silent dynamo, and with a silent dynamo came the collapse of the magnetic field. When that shield disappeared, Mars became exposed, naked to the violent solar wind. Over millions of years, the upper layers of the atmosphere were peeled away into space. Hydrogen, the lightest and most essential element in water, escaped the fastest. As hydrogen drifted off into space, Mars slowly lost the ability to retain moisture. With its atmosphere thinning, liquid water could no longer remain stable on its surface. Water requires a certain level of atmospheric pressure to stay in liquid form. When the pressure drops too low, water either freezes instantly or boils away into vapor depending on local conditions. On Mars, both of these processes occurred, sometimes at the same time. Rivers evaporated into the thinning air. Lakes shrank, then vanished. Ice locked in the soil sublimated directly into the atmosphere and drifted away. But losing the atmosphere did more than dry the surface. It cooled the entire planet. With declining atmospheric density, Mars's ability to retain heat dropped sharply. Without enough warmth and without a greenhouse effect, the surface temperature plummeted. Today, Mars averages temperatures of around 90 degrees Fahrenheit. At these temperatures, even if water existed, it would remain locked as ice permanently. Any melt would be fleeting, lasting only moments under the thin atmosphere before disappearing. Another factor that sealed the planet's fate is volcanic activity. On early Earth, volcanoes continuously replenished the atmosphere, releasing gases such as carbon dioxide and water vapor. This helped maintain a stable climate. Mars, however, is volcanically dormant today. The gigantic volcano Olympus Mons testify that Mars was once a volcanic powerhouse, but once the interior cooled, volcanic outgassing ceased. Without new gases to replace what was lost, the atmosphere continued thinning until it reached the near vacuum we see today. What about the idea of a Martian ocean? Several lines of evidence suggest that the northern hemisphere, which sits lower than the rest of the planet, once contained a body of water large enough to rival Earth's Arctic Ocean. Shoreline-like ridges, sediment patterns, and mineral distributions all support this vision. If this ocean existed, where did it go? Much of it was lost to space, carried away one molecule at a time by solar wind, but a significant portion may still remain, trapped underground as ice, locked in minerals, or hidden deep below the surface. Modern missions like NASA's MAVEN spacecraft have directly measured the rate at which Mars continues to lose atmosphere today. Although the planet has already lost the majority of its original atmosphere, hydrogen and oxygen still escape into space every second. This measurement proves that the process is ongoing, even in the present day. It also confirms that Mars's atmosphere was once far thicker, because it would require billions of years of continuous erosion to reduce a once dense atmosphere to its current thin shell. There is also the question of climate oscillations. Mars's axial tilt shifts dramatically over hundreds of thousands of years, far more than Earth's does. These variations can cause massive changes in climate, sometimes bringing warmer periods that allow temporary flows of briny water. Scientists have observed dark streaks on Martian slopes that appear seasonally, which may indicate small amounts of salty water briefly trickling across the ground. But these are minor remnants, shadows of a world long gone. So did all the water truly disappear? The answer is not entirely. A significant amount still exists on the planet, but in forms that are no longer accessible. At the poles, thick layers of water ice are buried underneath carbon dioxide frost. Deep underground, the soil contains frozen water mixed with minerals, a permafrost that could stretch kilometers below the surface. Some models even suggest hidden pockets of liquid subsurface water kept warm by geological processes. These reservoirs are potential habitats for microbial life, if any remains. Ultimately, the disappearance of Martian water is not the result of one catastrophic event, but a slow unraveling caused by multiple failures. A small planet that cooled too quickly, a magnetic shield that vanished, an atmosphere peeled away by solar wind, a surface that froze as temperatures declined, and volcanic systems that shut down before they could replenish the lost gases. Mars, in essence, aged too fast. It became an old world long before its time. Understanding this story is more than scientific curiosity. It is a warning. Mars shows us what can happen when a planet loses its atmosphere, loses its protection, and loses the processes that maintain a stable climate. And as we search for life beyond Earth, past or present, Mars remains our closest clue to how fragile habitability can be. Mars once had water, it once had warmth, and it once had potential. Today, it stands as a monument to what was lost and a reminder of how rare and precious a living world is. If you want more deep, clear, and fascinating explanations like this, make sure to like the video, share it with friends, and subscribe to Wiseuse. Your support helps us explore even more mysteries of the universe.